Hey everyone, my name's Mackenzie. Torsten on here with us, and welcome to another edition of Fermyon Live. We'll be going over challenge 2 of the Advent of Spin, which, if you aren't familiar, no worries. We'll be going through it all today. We're on challenge 2. This is a coding challenge that we host every year around this time. Folks tend to have a little bit more time on their hands, and it's a great opportunity to maybe learn a new tool or two. So this is our take on it. Torsten, how are you doing today?
Yeah, super fun. I just came back from the last conference for 2024. That was in Belgium. So yeah, was a great experience, meeting the community and talking about Spin and SpinCube just before winding down to, the Christmas holiday break. So all good.
Nice. That's great to hear. And viewers, as you're tuning in, definitely chime in the chat where you're joining us from. We love to hear, where you're tuning in from, maybe how you heard about Fermyon or Spin, and if there's any questions or topics you want to discuss along the way. We're super flexible. We'd love this to be interactive, so definitely feel free to chime in. All right. With that, should we go ahead and take a look at the description for challenge 2?
Yes.
All
So
right.
in the maybe before that, so in the last stream, so last week on Monday, we already coded through the first challenge, and the idea is to right now look at challenge 2 and extend the existing application by adding more stuff to it, right? So let's not spoiler that so far. And yeah, actually live code through challenge 2 before we will unveil or release challenge 3.
Yeah. Great context setting. And I'll put you on the spot. Do you still have your solution to challenge 1 up at all to show? Or should we direct viewers to YouTube?
Let me check. I think.
While you're doing that, I can give a verbal description. It is important to do these two in succession. Challenge 1, we went through and built a front end, a UI to help Santa basically store a long, collection of wish lists, which was backed by a Spin application that stored all of those in a key value store. So the solution for that is already up and recorded on this YouTube channel, so you can go ahead and take a look. And we're going to continue to add on top of that as the weeks go on. So definitely a good foundational piece to prioritize, and a great set of skills to learn. Static file server is super helpful. I think there are very few demo apps that we've put together that we don't use that one way or another. And same with the key value store for persisting state.
Yeah, so actually I found it. Let me bring in the link pretty quick. There we go. So people can actually browse it. Oh, I mean, that's maybe I will paste it also in the chat. So, I mean, I started. So channel 1 is really laying the foundation for the front end, right? Because we wanted to tell an end-to-end story, so that for challenge 2 and 3 we will build on top of that. But the feature set of the individual challenges do not overlap. Besides, maybe you decided to go with a plain HTML5 JavaScript CSS app, then you may add a new HTML page. I went the Angular route in our last stream, so I may end up adding new components. But besides that, the backend stuff is isolated, a dedicated new feature that we add to Center's new app.
Which is great. And you can take a look. It's got some nice artwork on here, and I shared it in chat as well. It's a good point. So you're learning new skills and adding on to it as you go. And this year, I believe we're planning on 4 challenges total. So just to give you a sense of pacing and, how long of a time investment this is. Cool. So now that we have a little bit of groundwork on challenge one, I think it's good time to explore what's up with challenge two and how we could go about potentially solving this. All right.
Right.
How's the font? Is that a little bit small? Or can you see okay?
Yeah, I think you can bump it like once or twice. That would
We'll try and bump it
be
up a
great.
little. There we go. All right. So again, we're going off of this theme, Advent of Spin. We have a strong holiday theme woven throughout all of these channels. It's fun to try and bring out your writing skills a little bit as we're putting these together. So we'll dive right into the spec. This is challenge two again. We've built our front end and our ability to persist a long collection of wish lists that Santa has. And let's see what's up for this week. This challenge is all about the latest spin feature called component dependencies, which allows you to seamlessly integrate remote components into your application. We highly recommend reading Spin 3.0 announcement post if you aren't familiar with component dependencies. And taking a bit of a pause on that, we did announce Spin 3 back in November, our latest major release. And if you aren't familiar with component dependencies, again, the blog post is great, but you're about to get some hands-on experience today if you're following along. So yeah, really excited about this challenge. Now that Santa and his elves can use the new app you've built, which is a point in favor for you on the nice scale, to manage all their wish lists, it's time for us to build a very important feature this week, the naughty or nice scoring. From time to time, Santa wants to check if a particular person was naughty or nice throughout the past year. A simple score on a scale from 1 being super naughty to 100 being incredibly nice will help Santa know how to correctly pack the right gift for the right person. Santa knows the key to a successful workshop is picking the right tool for the job. Some elves have delicate hand-carved tools for intricate toys, while others rely on automated machinery for super high-demand gifts. Each elf specializes in a different tool, which can cause bottlenecks in the gift-making process. And when thinking about this, Santa was really wishing there was a way to make all of these tools work together seamlessly. And while we can't fix manufacturing magic, we can solve this kind of problem in software. When designing the naughty or nice scoring feature, Santa decided to leverage the power of WebAssembly interface type. You may be familiar with this acronym, WIT, and the WebAssembly component model. These tools allow the API for this feature to be portable across programming language, so developers can choose the best workshop tool, in this analogy, programming language, for the job. Even better, you won't have to reinvent the wheel just because you're using different tools. Matt, the head elf, told Santa that Spin 3.0 added many features to streamline the developer experience when working with WebAssembly components. And that might be super smart to use those new features when implementing the naughty or nice scoring feature to streamline development and make his APIs flexible enough to fit anybody's workshop. All right, that's a lot of backstory, and you can kind of tell where we're getting at here and explaining why component dependencies are so cool. And it's one of those things that it's a little bit abstract, but once you start working with it and you realize, this really cool experience, similar to how you use libraries in regular, how you've typically developed applications to pull in functionality from other programming languages, it's actually pretty neat. All right. Going into the backend requirements, we're going to take this chunk by chunk. First up is the naughty or nice calculator using a WASM component. So although you can choose any programming language to implement the naughty or nice component, the elves are trying to tip the scale in favor of JavaScript or TypeScript. And we even heard from one of the elves that they found componentized JS and Jcode to be two great tools for bootstrapping WebAssembly components. And that, if you do use either of those, it might bump your naughty or nice, your nice score specifically up a point or two. And yeah, when we're writing this, we spent a lot of time going back and forth on how to identify a person's naughty or nice score without much success. It takes a lot of philosophy. Don't recommend it. And so we gave up and we're going to hand the power over to you. It's totally up to you how you calculate this. You could return a hard coded value, which would be easy, but yeah, you know, you could randomize the value, leave it up to fate, or you could implement custom logic to determine the naughty or nice score. Again, this is totally in your hands. And once you're done implementing your WebAssembly component, you can use Jco componentize command. The exact flags and arguments are documented in this really nice hyperlink to build your WebAssembly component. And then our tip here is also to avoid specifying the disabled flag. Cool. Torsten, what do you think?
Yeah, there's a lot to unpack. I mean, when we came up with this challenge, right, we tried to make it obviously challengeable, or a challenge for participants, but B, provide enough information so that people don't get stuck on the way of solving that particular challenge. And yeah, I think I could simply share my screen and we start working on that.
Cool. I'll take down the instructions, but for those following along, I'll add them in chat as well.
Okay, let me quickly come up with my screen. So there you should see my terminal right now, and let me quickly detach this window. So there is the challenge as well.
Nice.
So that I can, go forth and back and check with the requirements right now. I will also paste into the chat the link to the repository, which we were using, or which we created last week. This is on GitHub, and it's my, my personal participation of Advent of Spin. So we, as I already noted, we started with an Spin app using the HTTP empty template, and then we added a component to serve the front end and another component for implementing wishlist management using key value store, which is our API-wishlists over here. However, instead of starting from the spin points of view, the instructions of the challenge told us that we should start with a WebAssembly component in JavaScript. And I have already installed Jco and componentize JS on my machine. So if you follow those links, you will find detailed instructions on how to install those tools on your machine as well. So the WebAssembly component model book, maybe that's a nice one. So we obviously have some deep links, that point you to the right instructions on how to build WebAssembly components with JavaScript in that case, and provide, the commands that you can use to compile your JavaScript code down to WebAssembly. And we will actually do that as part of implementing the naughty or nice scoring component.
And so if you felt so inclined to try and use a different programming language, it looks like, going back to the book, there are instructions, but we know that the tool chain tends to be a little bit more robust on the JavaScript and TypeScript side of things, which is where we're trying to set you up for success, if I'm interpreting the elf's hint correctly there.
Yes, let's say for challenge 2, that's 100% correct. We have more challenges to come, right?
Yes.
Yeah, but overall, we try obviously to find so there are languages that are, pretty good when it comes to building and to building guest components or to act as host component languages, and there are others that still are in the phase of adopting that. So obviously we choose those combinations that work seamlessly and where people can also find documentation on how to do that.
Yep, exactly. While you're learning a new tool, might as well simplify as much as we can in the beginning stages.
Right. Okay. So this is our repository. So we have folders for the front end. We have folder for the wish list component. I have a tests folder where we have those Perl scripts that everyone could use before submitting his solution to Advent of Spin. And I will add a new one, let's call it WASM components, where let's go into that one, WASM components, and let's make a new dear naughty or nice. I would roll with that. And naughty or nice. So first of all, if you design a component, or we have to come up with some sort of interface, right, that describes how one could interact with our WebAssembly component. And the challenge instructions, if I bring those in again, nope, not this window. It's not this window. It's just a matter of cycling through the right windows.
Nested in there one place or another.
Yeah, there we go. So, nope, that's wrong.
Anyone who has tab management problems can understand.
It's okay as long as you don't have multiple windows with multiple tabs, then it becomes crazy. At least for me.
It works.
All right, so I was looking for this hint, right? So we were already mentioning that there is, where is it? The WebAssembly interface types? It's somewhere along
That
those
might
lines.
be beginning.
Yeah, exactly.
Where
Here. There. So WebAssembly interface types is basically a declarative language that you can use to lay out the, let's say, the API of your component so that others understand what you as an author expect from maybe a function call, which parameters or arguments it will receive, and what you will get in return of calling that component. And so it's always a good practice to start by designing your WIT world, how it's called. So the components view to the world, how that is. And that's what we will start with. So let's go to the terminal over here. We make a WIT folder, and we create within the WIT, we touch a new world.wit file. Let me open this folder in code.
And if you're not familiar, that same WebAssembly book we were looking at earlier is going to have lots of great resources if you want to dive a little bit deeper into WIT and the logic behind it and all that good stuff.
Exactly. And I think I will bring up the WIT documentation along the way of writing my WIT world, although the world is pretty simple, I guess. Maybe one hint, there is a VS Code extension also for WIT files, for WIT IDL, of the bytecode alliance. So I installed that one, which gives me, IntelliSense and syntax highlighting within or when writing WIT files. So for every WIT world, we have to come up with a package declaration. So there's a package, and we call that, let's call it components. And we call our component the naughty or nice component, and packages are always versioned, which means we have to specify the version of our package, and we start with or 0.1.0 over here.
Which makes a lot of sense if people will be writing applications that take dependencies on this, versioning and ensuring folks know exactly what they're pulling in is super crucial to providing a good user experience there.
Exactly, because you can pin the version, and you can immediately recognize from a new version that has been published by just looking at the version if that is maybe a bug fix, or maybe behavioral change, or maybe it is the public API of that component has changed since the release, or since that release that you pulled into your application. All right, so let's quickly go back. We have this component model book over here. And there is a dedicated section about WIT. And if we take a look at the structure of a WIT file, obviously we have like built-in components, and this goes beyond those 4 data types that WASM typically knows, because the WebAssembly component model allows us to use like more complex or more advanced data structures in designing components and in calling them across language barriers. So although we code in JavaScript, or we will code in JavaScript, we don't have to care, or we don't have to know how, for example, Rust lays out a string or other complex data structures in memory. The WebAssembly component model takes care of that. Although it's super important for me as a developer to express how my API looks like, or how I expect to receive like the name of the person for which I should generate a naughty or nice score. Besides data structures, we have worlds, right? So we have to define how our world looks like, or what we expect from a callee to actually do. So as you can see over here, we have interfaces, we can define functions, right? And it's actually the world that tells, okay, this component provides you something, so it exports a capability, or it expects from the consumer to provide a functionality. In that case, the world is importing a capability, like the error reporter over here in the documentation. So yeah, with a 2-minute explanation about worlds, let's just try to get through those requirements, because I mean it's super simple, right? We provide a name for a person, and we expect to get back a value if the person is nice, or if the person is naughty. Hopefully the score is pretty high.
One would hope. But that makes sense when we're thinking about the portability guarantees and also working across languages. There needs to be some sort of construct or some sort of foundational contract where you say this is what is needed in order for this to run successfully on an input side and also on an export side. And that's really
Right.
the premise of what we're building here.
Exactly. So we define a world, and I call that right now naughty or nice score, and we want to provide a capability. So we already know there is some sort of export. So we export like that function that someone could call. So we could obviously place the function right here, but personally, I prefer having like an interface for that type. So that's a scorer, let's say it that way, and that has a score function, which is function takes a name, right? The name of the person. We assume that is a string, and we just simply return, I think it is a score between 0 and 100, right?
Yep.
Yes,
Exactly.
1 and 100. Okay, super naughty is closer to 1, and super nice closer to 100. So this is a U8. So U8 is more than enough to represent that score. And finally, we can say, hey, this world exports the scorer interface. So this is basically the entire WIT world that we ask participants to come up with. Although you may end up with different namings for packages, for the world, for the interface, or even for the function. I mean, that's totally customizable. I just tried to come up with some meaningful names along the way.
Right.
So now that,
well,
yep, go ahead.
Just going to say, going back to the prompt, what's important is, taking the name and returning the score, which should be the common thing across all of the worlds that we see submitted.
Right. So now that we have the WIT interface defined, we can move on and implement. And the fact that JavaScript is a super dynamic language, or it is a dynamic language, so to say, not a super dynamic. It's just dynamic. We can simply say, okay, let's take care about implementing our business logic. And so we know we have to export So we have to export a const that is our scorer. The name does not matter, because all we have to do, if we look again at this, we have to export an object or something with a score function. A score function that takes a string and it returns an integer. So this is, in JavaScript module syntax, we can simply say, hey, I want to maybe do default export, or in my case, I do a named export scorer, which is an object that has a score function. And then I can, either do it in place over here, or maybe I want to, have different way of structuring my JavaScript code. I could also, have private functions in that module and just expose that particular function definition like here. So we can do a function score, takes a name, and then we can actually implement the naughty or nice scoring. So as the challenge already pointed out, simply returning 42 would work, but that's a little bit too easy. Although it is not about implementing some sort of business logic over here, we will do a simple math.floor, and we use math.random over here. I think we have to multiply this by 100, and we want to start from 1. So if this is our let's say business logic on how to determine if a person is naughty or nice, then we are already done. I mean, we haven't factored in the actual name of the user or of the person in ask right now. But I think there's more to uncover, because now we have that with Word and we have the lib.js file. We have to bring this together somehow. And my approach is okay, the instructions told me there's Jco, there's componentize JS, and we also link to command. So somehow I would want to execute that command. Let's go back and check. There is
back to the book.
Back to the book. Yes, there's this section of the book where we got linked to, and we see Jco componentize path to the JS and -- wit path to the wit world. Okay, so let's do that as a starting point, and let me bump the font size a little bit. Rearrange the windows again. There we go. So we have Jco componentize, and I did that already. lib.js -wit. So wit world. So we point to our world file, right? And I mean, a wit file could have more definitions. So we pick the world name, that's the naughty or nice scorer, and we say, please write the resulting WebAssembly file to, in that case, test.wasm. Let's roll with that, and then we change it in a second again to a more meaningful name for the WebAssembly module. So what this does, it checks if our code matches what is specified in the wit world, and if so, it takes the JavaScript interpreter and all the potential dependencies and our application code and evaluates the global scope so that everything is right exactly at that point to get executed, and writes that snapshot as a WebAssembly module to disk over there.
That's pretty neat. And if we had, for some reason, maybe accidentally passed in the wrong world, or missed something in our implementation, would Jco, bark at us or let us know that there's something wasn't quite right?
Yeah, exactly. So if we, for example, pass the wrong world name, we get an error. No world name, naughty or nice scorer 2 in package. So okay, the desired world was not found. Let's check what happens if we rename the export. So there is no score method right now supported by my JavaScript module. Okay, let's try that again. And we also get an error message. And I think along those lines, we see, yeah, try defining an interface alias scorer with a score function over here. So that's what is expected. However, my code does not provide those APIs or that particular function in that case. So the tooling is obviously there to, help us in the process of building reusable components. And yeah, so we had one additional comment, which is super important because I ran into that issue that the component model book has this -- disable all flag over here. And if you provide disable all, random number generators are also disabled, which means although you have like a random algorithm, it always returns the same value that has been evaluated upon wisening. So upon compiling, or when compiling your JavaScript code down to WebAssembly. All right, so this is important to get rid of that disable. And with that, we have a WASM file. Okay, so how do we make that repeatable? We can do an npm init. Let's do that. I could have passed --y to set the defaults. But at some point, again, I end up with my package JSON over here. And then we can just go there and grab the correct command. Where is it? There it is. Like this, and create a build script. And this is obviously language specific. So as a JavaScript developer, I'm used to run those npm tasks. Maybe if you do Rust, then you're using Cargo or other tooling, build RS, to instruct what should happen at build time. So yeah, you can seamlessly integrate that. And I think we call the component naughty or nice.
Yeah.
So the output should not be test.wasm. That should be naughty or nice.wasm. That's good. This
And then you have some nice attribution metadata, which again is helpful if you are downstream pulling this into your code as dependency. Understanding, where it's coming from is important.
Exactly. So hopefully, let's remove the test.wasm again. Test.wasm again. So now running npm run build, we expect a naughty or nice wasm file over here. Great. So this is basically the first part of the backend challenge. So should we continue with reading through the instructions, or?
Yeah, I'm happy to go over. Let's see, we're on to the naughty or nice HTTP API.
So I will remove mine from the stage and add yours. Is that okay?
All right, quick swap. There we go. Look at that. Screen sharing professionals. Okay, naughty or nice HTTP API. The elves expect a new HTTP API endpoint at API whack naughty or nice whack :name accepting GET requests, where :name should be a route parameter containing the name of the person. This time, the elves want you to use Rust. So we really are a polyglot programmer today for implementing the spin components. Michelle, one of Santa's most trusted elves, told us that the HTTP Rust template for spin dramatically simplifies writing Rust spin apps with Rust. Additionally, she gave us this hint linking to the spin language guide for Rust. We're pretty confident that you'll find this link super helpful. So we're going to have some nice templating and scaffolding coming our way. Now it's time to integrate with the naughty or nice WASM component you just built in the previous section using spin component dependencies and call the scoring function exported by the component. And it looks like Michelle has generously left us a few more breadcrumbs depending on how to import our dependency from a local component. The elves will try to invoke your custom naughty or nice endpoint. Then we'll expect the following information. First, the response with the status code should be set to 200. The content type header should also be set to application/JSON, and they should receive a JSON object with the response body using the structure below, which should look pretty familiar given the what world we just authored. And as the name of the person is set in the API as part of the URL, you might process the name in some way to make it a bit more human readable. All right. How does that sound? We're going to go ahead and build an API now.
Yes, exactly. So let me quickly take the stage again. There we are. Yeah, so I mean, Michelle gave some great tips, right? There's a template to get started. And we have a language guide, obviously for Rust and for all other languages, on what you need to install on your machine in order to make Spin compile your code down to WebAssembly. So let me quickly copy this one so that I don't have to write that. Let's go back to the root of our repository. So this is basically where spin.toml resists, and I could do a simple spin add to add another component to the existing spin application. As Michelle told us, we will use http-rust for this one, and we name it Nordy or naughty or nice, knowing that Rust does not want multiple spaces, dashes, if I remember correctly.
Good catch.
So let's call it naughty or nice. Let's stick with the default description. And let's pass in this as the HTTP path. So this basically tells the Spin runtime, hey, for requests, hitting /API/naughty or nice, and everything behind that, please invoke our naughty or nice Spin component. And this looks, yeah, my font looks a little bit weird, but that's correct. Okay, cool. Let's check what we got. So we have spin.toml. We see this is modified over here. We expect new components to appear at the bottom. So we have that HTTP component, everything wired up here correctly. So we can...
This is a small shout out for spin add, especially if you write your own templates, right? You get the default HTTP and programming language for what we support in spin, but as you start to build more applications, you can templatize your own custom logic and add that to applications with spin add as well, which is super neat.
Yeah, definitely. And now I see that I had a naming pattern in place, and my app, my latest edition, does not fall in line with the API-wish lists. So sorry, but I have to recreate that because I'm pretty, I want to name things correctly, and it takes just a second. So let's go to there, and let's say spin add HTTP Rust, and it is API naughty or nice. Okay, so now I'm satisfied with like how things are named, and I want to pull up the trigger definition to the top of my spin toml, but that's just personal preference, right? That gives me a nice little overview. If I open up the spin toml, I can immediately spot, okay, there are multiple component or multiple triggers in that app, and I can see when which component is desired or will be invoked. Cool.
And if you've been with Spin for a while and you're looking at this application manifest and thinking it doesn't look anything like the ones you're used to, this was a while back, but we did update the manifest, I believe, as part of Spin 2.0. So we have plugins, Spin Doctor, to help update your application if that's the case. So just a shout out, if you've been with us and doing a few advent of spins, that might be a good update to consider.
Exactly, that's a great tip. Yeah, if you have a manifest version of one, Spin Doctor can help you move towards Spin Manifest version 2. Cool. So now it's time to implement the naughty or nice Rust component. So I will open up a new code instance to make my Rust language server implementation for VS Code happy, so that it can actually, take care of that one. Cool. So we should accept let me check. We should accept a name parameter and it's a get request. Okay, so we can use the HTTP router we could, tinker around with the request, look at the method and try to grab values from path, but we have a router and it's way more convenient to say, to define how you expect your app to behave or how it should respond to different circumstances. So let's quickly create or lay out the app. So we say there's a get to /API. Now I have to bring in this again, naughty or nice.
Smart, copying the path.
Yeah. Name, and we should say get naughty or nice score, something like that. And finally, we tell Spin that the router will handle the request. There we go. And finally, we can implement, we get a request. That's request from the Spin SDK. We may want to read param meters over here. That's the params struct from our SDK. And we want to return an anyhow result. So for convenient reasons, let's bring in anyhow into scope that implements the into response thread. And if you work with TypeScript or Java or C#, you can think of a trait in Rust as of an interface in those languages. So basically, it defines how behavior is implemented on a Rust struct. So what Spin asked us to do is basically return something that Spin could turn into a response. Okay, so first of all, the Rust compiler is happy with that right now, but it's not happy with my function because it does not return a response yet. So let's make that happy by simply saying, okay, response new 500 and with an empty body. So, okay, this is like my to-do. Hey, let's, in the case that I mess up right now, we always end up with HTTP 500. You could also use the to-do macro, but yeah. Cool. So first we have to extract the name from parameters get and name. We could, use different ways so this returns if I remember correctly, an option, right? That could technically be none, but our route constraint on the router enforces that the value is set. So we can, for example, unwrap over here, or we could say unwrap or we could expect it. Unwrap or expect it. Let's stick with unwrap. And let's add a nice little comment, enforced by the spin router. So with the name in place, we somehow would bring in like our JavaScript based component, right, to get the score for that person. And to do so, we have, as part of Spin 3, released the Spin Depth plugin, so that if we go to Spin 3.0 release, there is a nice post highlighting all those major improvements that Spin 3 provides. and we have component dependencies, and you can find a link in here pointing you to detailed documentation on how to use component dependencies. And also, as part of this documentation, you can identify how you can load. Oh, there are different sources where you can load components from. We will use them or load them from the local machine because we have the component, the .wasm file, already on my system. So I'm just trying to double check where the link to the GitHub repository is for people to install language guides and a component model book. So many links.
Right, we're well covered.
I was eager to add many links to the component dependencies. That's this language guide.
If you haven't read the 3.0 blog post, again, it's pretty long between component dependencies. If you're more on the platform engineering side of things, selective deployments, but you look like you have a question.
Yeah, I just trying to double check where. So there is, as you said, Kenzie, it is pretty long. However, there's a link in that article pointing to the depths plugin. That's what I basically wanted to say. So there's a spin depths plugin. There you go. There was some component published to registry, Fermyon packages. Okay. And at some point, I think we have a link on to that.
I'm gonna try and race to you and see if I can find it. But it's an experimental plugin that kind of helps streamline some of this.
Exactly. So let me bring it up. That's github.com/fermyon/depths.
Whack plugin.
Is it whack plugin? Depths?
Or dash plugin, yeah.
Nope. Let me.
I'll send it to you over chat.
Okay, cool.
And then I'll also throw it on a banner for those following along at home.
Okay, copy link address. There we go. Spin-depths-plugin. Yeah.
We got it.
Finally. So this is basically the magic, right? This is a plugin that a couple of colleagues of us wrote that makes Spin or adds a new subcommand to Spin that allows us to say, hey, I have a WebAssembly component and I want to add that to my existing Spin application, right? So I have installed that. It's basically Spin plugins install. So this command again here to install that. And so now that the compiler is happy, which is, I think, super important, let's do spin depths wasm components naughty or nice .wasm. So we point in the folder where our spin app persists. We say, hey, I want to add a dependency. And by the way, here is that WebAssembly module, right? My dependent module. And spin depths looks at that WASM file because WebAssembly modules are self-describing, right? Although it is just that binary representation, it provides all the information that, for example, tooling like spin depths needs to identify, hey, there is a component, and if you closely look at this string, it's components :naughty or nice in version 0.1.0, which basically is the package information that we specified in our WIT file. So we select that, and then it says, hey, select one of all the interfaces to import from that particular package. Yes, we have a scorer interface that we want to import, and now it iterates over all the components of the current spin app and asks, hey, which component should I add this as a dependency? So we ensure to select the API Naughty or Nice over here. And there we are. What happened right now is that if we go back to our spin.toml and scroll down a little bit, we can see that for the naughty or nice component over here, a dependencies table has been added. And that dependencies table basically says, hey, bring in the naughty or nice scorer from version 0.1.0. And by the way, you can find the WASM file over there.
On the local path. That's super neat. And we've been doing a bit of a one-man band show here where you've written the WebAssembly component and brought it in locally. But as you pointed out, you can pull these dependencies from OCI registries as well and use this plugin to do that. So if you wanted to pull something from a colleague stored elsewhere, that's totally a flow that's supported as well.
Yep. All right. I was just double checking if my screen, if we were sharing my screen, or if I was,
yes,
if I was talking. All right. It doesn't stop here. So spindabs also has a subcommand that we can use to generate language-specific bindings. So remember, we have written the business logic in the naughty or nice score in JavaScript, and we want to consume that in Rust. So we can say spindabs generate bindings, language, Rust, naughty or nice. So I think we have to specify API naughty or nice. This has a source folder and we want this in bindings. And what else do we have? There's another thing. We must specify the component -id. That's the component ID from Spin. So let's go to there. That is API naughty or nice. All right, bindings generated for Rust in API naughty or nice source bindings. You need to add with bind gen create to your Rust Spin app. Okay, we also got these instructions over here. Let's copy them and let's clean the surface for now and go into API naughty or nice. And let's follow the instructions, cargo add with bindgen. And I think we may have to add 2 additional crates, but let's check if we do a simple spin build over here that builds like all our components. It could be required that we add 30 and 30 JSON as a dependency as well. So 30, no, it looks good. Okay. It's just complaining about my code, not about the generated one. Oh, but we will see. Cool. So we have that in place. And if we go back to, let me bring in the proper, this instance of VS Code where we started implementing the API, we see a bindings folder over here. So once we bring that into scope by saying, hey, there is a module that I want to use, the Rust analyzer will, kick in again and double check all the code that has been generated for us, which is this pile of code. So this gives us, you see, a public module called Scorer. So this obviously is dependent on how you called your world in WIT. So we can bring that in, and there we can call the score function, pass in the name, and we receive back a U8, which is great. Let's say this is our score. And finally, we have to come up with 2 things. Let's check. Where is the... We go back to the challenge. because we have to come up with name and score as a response scheme, we have to set the HTTP header. And yes, so if I send John Doe, as in this example, as a route parameter, so as a URL parameter, we have to take care of URL encoding and decoding either way to make it human readable again. So first, let's come up with the structure and let's ensure that we have the response specified with everything that is required. So I prefer having like a pub struct response model over here. We have a name, which is a string, and we have a score, which is a UH, right? And we want to derive. So now I want to derive serialize over here. So serialize is a capability that the SERDI crate provides, that I can mark a struct in Rust with that macro, with that attribute, so to say, and then it automatically gets the capability to be serialized and deserialized if we not care about the other way around. So it is cargo at SERDI. And obviously we want to talk JSON, so cargo, oh no, that was derived feature. And then we do a cargo at SERDI_JSON. Okay, now we can bring that into scope. There we go. And we say at some point, let result equals new response model over here. No, not new. That was wrong programming language.
Makes sense. You're flipping between two.
I've been writing some C# recently, so let me set the name to, and I think we have to clone over here. Maybe we have to clone earlier because this one gets ownership and name is a answer. Okay, so we can say string from. So I don't want to go down the rabbit hole of specifying lifetimes for stirs on the response model. Instead, let's just say create a string from that one, and we do score. Score is a U8. U8 implements a copy trait behind the scenes, so that one will be copied in memory if required. But strings in Rust are a little bit different. Okay, so we have the result. So let's come up with a meaningful response. That's response builder is what I prefer to using for responses that are more sophisticated than just status code plus a plain body. So you can use this one to say, I want to set a header with content type being set to application/JSON. And nice. I want to set the body to result. And finally, I want to build. So now there are different ways on how to make this code work. We can serialize result to JSON before passing the variable to the body function over here. Or a little bit more robust way, we could also say impl the into body, trait for response model. And basically it tells, hey, given an instance of the response model, I have to write that code to turn that into a vector of U8. Luckily, SERDI_JSON provides us with the toBack function over here, so we can pass itself. And let's say we're pretty confident that every instance that we have is able to be turned into a U8 representation, or an array of U8. Cool. So let me quickly check something. This is good. This is good. So there's one missing requirement. So far, we just take the name from the URL route parameter as it is, right? So we may end up with, I don't know, with Will, no, with Jane, because we have John Doe. Let's add Jane Doe.
Balance it out,
So,
yes.
so we end up with something like this along the line, right? So we have to decode that. So my way of fixing that would be creates.io, because I don't, my task is not writing URL decoding, URL
Nice.
encoding, URL decoding, maybe URL decoder.
And I would say this might fall in the extra credit bucket if I'm looking at the README correctly. It says you might want to make it human readable. So,
Oh, I thought I would. I thought I made that mandatory.
well, we'll see. Maybe don't listen to me. Check Hurl.
No, good. I'm just double checking which crate. I think there is a URL encoding crate. Yeah, this is way more popular. So this looks convenient, right? So there is cargo add URL encoding, and then I get like, instructions on how to decode URL encoded string. Great. Let's do that. Let's go there. Let's bring that in. Finally, I would do a shadowing over here. I would say name is equal to decode. And now I can just pass in the name again. So this returns, this may fail, obviously, right? This returns a result of call string. Okay. So let's say we do question mark over here. Spin will automatically return with an HTTP 500 if that fails. However, this is right now call stir, not stir, or reference to a string. So I could again do like name equals name dot into old. And now name is a string, and this one wants stir. I think that there may be super more elegant ways how to implement that, but bear with me. I think that's okay for now. Okay, let's make the Rust compiler happy so that it stops yelling at me when compiling. Remove everything. Yeah. This one is just an extension that tells me that I did some misspelling. Naughty or nice. Okay. There's something else. Okay. This is
by my clock, it's taken us longer to write the API than the WebAssembly component, albeit it was a pretty simple WebAssembly component.
Okay, so yeah, you're right. I have to finish this one. Let's go to the terminal and let's do a final test. If we do a spin build over here, it is hopefully correct. There we go.
Nice.
So should we test it before we look at the front end? Yeah.
Yeah.
Okay, so naughty or nice on localhost 3000, and it's simply curl this, and I get 31.
Ooh.
Oh yeah, I take this one. I take 92. I take 92. Like 1 week before Christmas, I take that one. Yeah. All right. Yeah, so that seems to work. We end up with random scores for the naughty or nice. Cool.
Beautiful. Should we figure out a way to expose this data to our end users?
Yes, we have to.
Yeah, we can't expect Santa to be making API requests. He's far too busy for something like that. So the last piece, hopefully a quick one for you to put together, because we know this was a meaty challenge. So kudos to you for following along. Is front end requirements. So we're going to add a new view or page to the front end that you created as part of challenge 1. which is going to allow our customers, Santa and his elves, to enter a particular name of a person and invoke the naughty or nice scoring API we just added to the backend. So this is important because we want to get credit for our work. The elves are going to check if the naughty or nice scoring UI is available at either index.html, naughty or nice for SPAs, or naughty or nice.html for plain HTML5 front ends. So to pass the hurdle test, we got to make sure we're meeting those requirements.
Exactly. So this should be like a quick one. Famous last words, right?
Yeah, extends into hour two. I'm trying to build front
Let's go
end.
to the front end folder. So this, yeah, I started challenge one with Angular, and let's continue that. So ng generate component, and let's call it naughty or nice. There we go. Let's open up code over here, because then we are like language servers for Angular are happy right now. And so we ended up with a new component, naughty or nice. I mean, it says, I think it says naughty or nice works, right? This is Angular's default template. So we have to add a new route. And we had like precise instructions how to call, or which URL the route should respond or be discovered at. So this, and we have to link that to our naughty or nice component. Awesome. So finally, it's let me check. Just double checking on my. Just double checking if I did everything correct so far. Just give me a sec.
A quick mental scan.
Yeah. All right. Because I don't want to, waste time in writing HTML and forms and stuff like that. So I think we had in challenge one a task to add a wish list to the list of all wish lists. So I will copy that. So to have like a good starting point. And now some great refactorings over there. This is the naughty or nice scorer. We have to provide a name. Yes, that's correct. Name, min length 3. Okay, provide not your name. Let's say provide a name. And we will have something as a result, which is the score, right? That's a score. So label form for score. And instead of a text area, let's do a simple input type equals text. ID is score. We don't have rows over there. We have a name that's score. We have an ng model that's score. We have a min length. We don't have a min length, and we set it to read only. So that
overriding.
Exactly. And no overriding. That's correct. So with that, I think this is okay for the form. It's not, let's say it's developer nice or engineering nice, but it's not nice. Okay, so we have to take care about bringing in, this is Angular specific, so we have to, make two-way data binding work and stuff like that. There's a forms module, but basically we have like a protected, we have the name, right, which is a string, and we start with an empty string, protected score, and this is a number, and we start with a 0. So somehow we have to communicate from the front end with the back end. This is usually in Angular done by using services. So we say generate service naughty or nice over here. This adds a new TypeScript class called naughty or nice service. And the naughty or nice service will, like the wishlist service we had before, send an HTTP request to the backend. So we use private read-only HTTP, which is HTTP client, TTP client, and we have one function over there, public get score, public get score. That takes a name, string, and returns an observable of, and we have to come up with a new model, right, to represent how the data structure looks like. That's the naughty or nice score. That will be a class that we create in a dedicated file, as we did for wishlist over here. Oh, I know why I was confused why it's squiggle lines under the public the entire time. That was just because I didn't close the constructor correctly. But finally, at some point, we can say return this HTTP get. That's the get call. We expect naughty or nice score from our API, like this, and our API is at API/naughty or nice, and we have to pass in the name. And this is obviously a dollar sign. Okay, so let's add a new TypeScript file. Let's call that naughty or nice score.ts over here.
They're going to start to blend together.
Let's say this is the naughty or nice that has a public string, and instead of this, it has a score, which is a number, and it has a default value of 0. Make that nice. And there we go. Update the imports over here.
Question for you. With our default value of 0, is that intentionally off the scale? Because I think we're returning a number between 1 and 100.
Huh. Good catch. Let's say yes. No, it's
that way we know it's default.
Yeah, I mean, it's we could also come up with a data type that says, I mean, undefined or number, and set it to undefined. That would be like a smarter way of doing it. Yes. So yeah. So like this, right? We could do that. So I hope I haven't done real world Angular in ages, and I hope that two-way model binding is happy with this approach. But yeah, this would be another way of doing that. Yeah. Okay. Last piece is basically implementing. We had a function call here, ng on submit. So this is basically user enters the name, press the button. We want to call our function. Let's do that. ng on submit, and we have to bring in to do that. We have obviously to bring in the naughty or nice service. Again, Angular is, as far as I know, using constructor injection heavily. Private read-only naughty or nice service, and that's the naughty or nice service from there. Open closing brackets. We could gate that. We could say if this .name.length is lower than 3, and we expect the form not to be filled correctly, so we simply return. Otherwise, we could do naughty or nice service get the score for this .name, and there are smarter ways of doing that in Angular, right? We could take that it's observable, bind that with the async pipe to the front end, but yeah, we want to keep things simple. there's room for improvement. That's it, right?
Yes.
Uh,
But we're
so
covering a
we
lot of ground today. We're doing some full stack engineering, so that's okay.
Yeah, so that's like the let's say the simplest way to just say, hey, we expect that to be executed once and we get a response back immediately. We don't take care about errors over here, right? We just tightly couple the response to the model that we have over here. And again, we could also have called the naughty or nice score constructor in the first place, bind to a like complex data type and use that with ng model, or we could have used reactive forms. There are so many ways of achieving that. But I think I'm done. Let's try.
All right.
Fingers crossed. Let's do a spin build.
That would put us 2 for 2. Oh, it jinxed us.
Oh yeah, unexpected closing. Yeah, it's HTML. Most complex stuff is like this. Go away. What's in there? Let's take. Maybe for those of you who haven't participated in the first challenge, one small hint, because we were using the trying to find it. So we are using static file server to, make spin serve the compiled version of the Angular app. And there's although there is usually no build command for the static file server, you can specify one and instruct like spin build to compile Angular on the go. That's basically what I did over here. So for every build of my spin app, it builds the entire Angular app. And the result of that build step is then served by the static file server, as you can see over here. That everything in app, and in app we always have like the most current compilation result.
Oh, nice. That's handy.
So it builds. Let's do a spin up. Oh, I have some spin app running somewhere. So let's do a spin up again. Let's click the link. And I forgot to add it to the top level navigation. That's what we discovered. I discovered quickly. This is app component, I guess. Yes, this is correct. Let's say this is the or nice. And let's go to routes and let's copy this.
Take no risks. Not this late in the game.
Exactly. So we can do a spin up dash build.
Great pro tip for reducing the number of
We're getting lazier and
spin.
lazier. We're getting lazier and lazier the more we progress in the stream. There we go.
There we go. Nice.
Let's check. Okay. Fingers crossed.
Oh.
It works. We get back random values. I mean, it's not nice. The form is not nice, but at least I got a nice value, nice score.
Back to our 90s. Fantastic.
All right. So final step, as for every challenge, is somehow verifying that we did everything correct. And as part of the challenge, and I will bring the challenge up on screen over here, we have test scripts that everyone could run. So there's a dedicated one for those who went with a default HTML5 template, and another one for those who use single page application frameworks with routing capabilities. So I already downloaded that file to my, let's show it to you, to my tests folder over here. You can see that's double checking for naughty or nice HTML. That's invoking the naughty or nice score and expecting application JSON, John Doe with the decoded variant as a response, and a score between greater than 0, lower than 100. So as I have my spin app still running on localhost 3000, we should be able to go to the tests folder over here and simply do hurl test. Yeah, that's almost correct. Hurl test C2.
And if you
there we go.
deployed nice to Fermyon Cloud, you could update the URL to your domain name test there as well.
Sure, exactly. That's a good hint. Yeah, let's finally do that.
And if you get to this point and hurl bonks at you, we are here in Discord to help.
All right. Yeah. So, but besides coding through challenge 2 is what we did, we have an additional task to achieve right now, which is basically pushing this to main, right? That will release challenge 3.
Oh, yes. Folks got to do something next week.
Okay, so let's do that, right? Let's do push.
All right, and if you made it this long, you've walked all the way through the solution, one potential way of doing challenge 2, and we are releasing challenge 3 for the upcoming week, which we'll go over next Monday.
Right, exactly. So there we are. Challenge 3 with that is live. In the meantime, my app is, I think, still deploying. Let's check. It went off spin. This looks like mine. Oh, and mine would be good to for submission, right? So it is deployed to Fermyon Cloud. And again, let's check if. Oh no, I'm not that nice.
It really likes to start low before it goes up.
Yeah, there was a 94, but I clicked again on it. But yeah, I hope still.
I don't know. Just keep that's the beauty of the random logic.
Yeah, I have to implement some special logic for my name, I think.
Yeah, if name starts with T, 100.
Yeah. Alrighty.
Oh, well, so challenge 3 is up. We shared in chat, but the working repo, so if you need inspiration or on previous challenges or want some hints, that's a great resource. We're here on Discord. And yeah, we'll be back this time next week for the solution to challenge 3.
Yes, give me just 5 minutes after the stream. I will clean up the repo, push that also to GitHub. And we'll figure out challenge 3 next week.
All right. Well, congratulations, everyone, for mastery of component dependency. That's pretty cool. Yeah, thanks for tuning in.
Thank you.
All right.
Bye-bye.